Hello everyone, my name is Chirag Kalra and welcome to the course. In this course, we are going to build an e-learning application like Udemy using React and ASP.NET. Now, let's start by taking a look at the project. The project is called LEARNIFY, which is an e-learning application. If we take a look at the homepage, we will see a list of courses as expected from an e-learning application. As you would notice, we have pagination going on here, which shows 8 courses in a page. If we click on page 2, we will see 8 more courses. On the top left, we can sort courses on the basis of price. By default, they are sorted alphabetically. We can also filter the courses by category, such as IT software, languages, or music. We also have a search bar where we can search for a course using a keyword. So if I search AWS, I will find a course which has a keyword AWS in it. Let's clear it. If we click on any course's title, we will be taken to the description page of the course. This page has some detailed information about the course, like the instructor of the course, language of the course, learnings, requirements, category, level, and some description. Right now, I have just used the placeholder stuff, but you can add any information as you like. You can also add the course to cart from description page. Now, if you go back, if I click here, we will see that the cart icon gets updated to 1. You'll also notice that add to cart has been changed to go to cart. If we click here, we will be redirected to the basket page. Here we see some details about the course, the total amount, and the checkout button. Now let's go back and add another course to the basket. Let's add this one and let's go back to the cart. We would see that it automatically creates the total for us. Let's keep only one course for now. Let's keep full stack Python with Django, and I will delete this one. Now if we click on checkout, we will be redirected to the login page, because we need to log in to proceed further. I'll just log in with one of the users. After logging in, we will be redirected to the profile page. Right now, we don't see any course because we haven't purchased any. But if we see our basket, we have a course already. Let's click on the cart and go to the basket page. And now we can click on checkout and we will be taken to the checkout page. We need to fill in our card details here. Of course, we will use test credentials, not the real ones. And we are going to use Stripe as our payment service. And now I can click on make payment. As you can see, we see your payment is successful. Also, on our profile, we see the course we just purchased. Let's click on go to course. And now we can see our course. Now I can choose any video and that video will be running. If we go back to our profile, you will see that we have an option to become an instructor. You can click on that button, and now if I open the menu, we will see an instructor drop down. Let's click on instructor. We immediately see an option to create a new course. Now if I click on it, we will see some fields related to the course. Let's fill some details. For simplicity, I will write test course. And I will use it everywhere. Let's keep the price to be $11.99. Category can be languages. Level can be beginner, and the language can be English. Let me click on submit. Now on our instructor page, we can see our unpublished course because we just have created some information, but we haven't published it yet. Now, if I click on this course, we will go to another page where we can write the sections and lectures. I will simply write section 1 and add a lecture to it. Let's call it lecture 1 and URL 1. Ideally, we should write the link to the video, but I'm writing this for simplicity. We can publish this section and finally click on publish course. Now, if I open the instructor page, we will not see it inside unpublished courses because it's already published. Now we can go to the home page and go to languages. We will see our new course, which we just created. We can see it here because this has a category languages. Well, this is the application we are going to build. This course is designed for people who have little knowledge of React and some knowledge of an object-oriented language such as C#, Java, or C++. If you find this project interesting and you aspire to build a real-world project like this, I promise you will learn a lot from this course. See you inside.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.
Let's talk about technologies we are going to use in this course. In the front end, we will be using React.js, which is the most popular JavaScript framework. React is a good choice because it has a faster learning curve if you compare it to other libraries such as Angular. React is backed by Facebook, which ensures that it's not going anywhere. In this course, we will be using React with TypeScript, which gives us type safety in compile time. It's amazing because it simplifies the JavaScript code and makes it easier to read and debug. It supports static typing, which means a variable has a defined data type, and if you try to change it, it gives you an error. It's essential because as a developer, we want our code to be organized. It also supports all the latest JavaScript features, so there are no obstructions if you want to take advantage of all the new JavaScript features. Now let's talk about SAS. It stands for Syntactically Awesome Style Sheets. If you haven't heard of it, it is the more advanced version of CSS. It is a preprocessor scripting language that is interpreted or compiled into CSS. In short, it provides us more features than CSS, and it's better for development. You can use variables, operators, placeholders, and so much more using SAS. Now for the state management, we will be using Redux toolkit. It gives us all the features of Redux without the boilerplate code Redux has. In Redux toolkit, we have slices. So one component will have one slice, which will be responsible for everything: actions, reducers, and thunk. They used to exist in different files before, but now all the related code will be centralized inside Redux toolkit. Now this is what we are going to use in the client side. Now let's talk about our backend. ASP.NET is going to be our protagonist. It has gained so much popularity that it became the most popular backend framework in 2020. It is way faster than any other backend service. Also, it's considered perfect technology for enterprise softwares. Now you can imagine how much highly rated this framework is. This is an era of microservices, and if you want to build one of that, ASP.NET is a great option. We will be using SQLite as our development database. It's very easy to install and it doesn't require to run any servers, which makes the development process very convenient. I know we can't use this as a production database, so we will be using Postgres as our production database. It is a very popular relational database service, and most importantly, Heroku gives us an option to run Postgres database server for free, which means we can host our entire application on the internet without spending a single penny. How cool is that? And now, since we are talking about deployment, let's see where we are hosting our project. Heroku provides some amazing deployment solutions, and we will be deploying our application on Heroku with our database deployed on Postgres, which again is provided by Heroku for free. I chose Heroku because it takes only few commands to take your application to the internet. It also gives us an option to create a free database. Now these are the main technologies. There is a lot more covered in this course. For that, let's move on with the course. Since we are building a web application and we want a robust technology, we will be using ASP.NET Core to do this. First thing you need to do is go to the website .net.microsoft.com/download and download the software development kit. In this course, we will be using version 5. And in version 5 and all the future versions, Core is omitted from the name, and hence it's called ASP.NET 5. So get used to call it .NET instead of .NET Core. At the time of recording this, the version 5 is the recommended version. Although the preview version 6 is also available, but it can't be guaranteed that all dependencies we are going to use in this course are compatible with version 6. We won't be taking that risk, so go ahead and install version 5. Don't worry about the version change. The library is very mature and in almost all situations, changes are not breaking. So there is nothing to worry. As ASP.NET is a cross-platform, downloads are available for Windows, Linux, and Mac OS. You can also install it in a Docker container. But I'm going to download the Mac OS version, so pause the video and come back once the downloading has finished. Once it's correctly installed, open the terminal and type .NET -info and press enter. You will see if it's correctly installed. You can download multiple versions at once, as you can see in my terminal. So once you have installed it, you will see it in the terminal. Now, once we have downloaded this, let's move on and install Node.js. Once ASP.NET is installed, we will also need Node.js, which comes with NPM or Node Package Manager. NPM will help us install the dependencies we need for the React project. Coming to which version you need for this project, either of them is fine. If the version is above 10, there will be no issues. If you already have Node installed, check the version. If it's later than 10, you don't have to install another version. If Node is not installed, you can also download the Node Version Manager, which will help you maintain different versions. One thing to keep in mind is you can only have one version of Node installed in your computer, which is unlike ASP.NET, where you can have multiple versions running simultaneously without any conflicts. So, if you want to run different versions of Node at the same time, download and install NVM or Node Version Manager. So once it's correctly installed, open the terminal and type node-v and press enter. You will see the exact version installed. As I just told you, you can only install one version at a time. Now once you have installed Node, let's move on and install Visual Studio Code. For our code editor, I will be using Visual Studio Code. Since this course is for people who have some programming experience and you might have your own preferences. I'm using VS Code because it's cross-platform. People watching this course might have different platforms, Windows, Linux, or Mac. I want to give you all the same experience despite your platforms. Visual Studio Code is a good choice for this. VS Code has some amazing extensions which we can take advantage of. It also provides great debugging support for .NET Core. I'm not saying this is the perfect code editor, but it fits all our requirements. Once you have installed VS Code, let's move on and install Postman. We have downloaded the must-have softwares for this course. This is now a strong recommendation. I highly recommend using Postman to test the API. We are going to use Postman extensively, and this makes the development process very convenient. If you haven't used Postman yet, you can start using this and you might never want to use something else. But if you're comfortable with anything else, that's fine as well. I have prepared a file with all the requests we are going to use in this course. The file is only compatible with Postman. So if you're using any other software, you will have to write APIs manually. So these were our environment dependencies. In the next lesson, we will see and install VS Code extensions. Now that the environment setup is ready, let's install some extensions which will make our lives better as a developer. Go through this lecture only if you're using VS Code as your code editor. Lately, VS Code has become very smart. Developers have worked very hard and made some amazing extensions that support various programming languages and tools. Mind you, this is not an IDE, and I don't expect this to be as productive as an integrated developer environment. But trust me, it's getting better and better every day. Let's talk about the most essential extension first. On the left, click on the extensions and search for C#. Install the one which is powered by OmniSharp. It's a lightweight development tool for .NET Core and it has great C# editing support. It includes syntax highlighting, IntelliSense, debugging support, and much more. Once you have installed this extension, let's move on to the next one. So this is our painkiller. Now let's talk about some vitamins. All these tools are optional but good to have, and the first one is C# extensions by jcanon. Although this one is not under development anymore, but it does its job pretty well. We will be using this extension for creating classes, interfaces by just one click. It also helps us creating constructors and also in initialization. We will be using it all the time. So we will talk about once we start using it. Now let's talk about the next one, which is NuGet Gallery. NuGet Gallery provides us access for the NuGet package manager, which is like NPM of ASP.NET World. We will be using it to install our dependencies. This makes installing new packages very convenient, and we can also do it from our command line, which is cool. You can also use Prettier. This automatically formats your code. Prettier is a very popular extension with more than 12 million downloads. It's primarily used for JavaScript, TypeScript, Flow, JSX, JSON, CSS, Sass, Less, HTML, Vue, Angular. Also, it can be used with GraphQL, with Markdown files, with YAML. We can use it to format our JavaScript and CSS code. This one is very good to have. Our next extension is Bracket Pair Colorizer. So you can search for it, Bracket Pair Colorizer. This will color your opening and closing brackets with the same color. It's very helpful when you're dealing with a lot of code. Now the next one is Material Icon Theme. To make your files and folders look better, you can install Material Icon Theme. Again, it's optional. If you don't like the look and feel of it, feel free to uninstall it. It's just that I use it, and if you want your project to look the same as mine, this is what I use. And the last one is SQLite. We will be using SQLite for our development database. Once we deploy our project to the cloud, we will switch it to a production-ready database. Well, that's about it. We are all set to work on our project. Let's start coding in the next lesson. Finally, it's time where we start working on the project. First of all, open the terminal and check if .NET SDK is correctly installed. Use the command .NET --info and press enter. Now the latest version I have is 5.0.201. It can be different when you are watching it. As you can see, I have multiple versions. I have multiple versions of SDKs and runtimes. And as we discussed before, we can have multiple versions running simultaneously. If you're confused what is the difference between SDK and a runtime, SDK is a software development kit, which includes stuff you need to build and run the application, such as the CLI and the compiler. Whereas runtime helps to run the apps which are already compiled with the SDK. I hope it makes sense. And don't worry if version 6 is out and it becomes the latest version. Most probably the changes won't be breaking, and if there are, I will make appropriate changes to the course. Now that the software development kit is correctly installed, type .NET-H to check all the available commands. Out of these commands, new helps us to create a new project or a new file. Run will build and run the application. SLN command will create a solution file, and watch command will start a file watcher which will keep our server ready with the changes, and we won't have to restart the server again and again. Now what we'll do is clear the terminal and type .NET new -L. This will give us list of templates available to us to create .NET related project or files. Out of these projects, we will first create a solution file using the SLN command. Solution file will work as a container for the applications project. If you're using VS Code, then solution file helps to build all those projects which are part of the solution just by running .NET build command. We'll also be creating web API project. This will be the starter project which will actually run our application. We'll also be using the classlib command, which helps to connect other projects to our web API. For example, if you want to create a different project that takes care of the data and interacts with the database, you can create a class library and later on add a reference to the main project. Now that you know all the commands available, go to the directory where you want to store your project. I will create it in my desktop, so I will go to the desktop and make the directory called LEARNIFY, which is the name of our application. Now let's cd into our project. Once you're inside the project, create a new solution file using .NET new sln command. This command will automatically take the name of the parent folder, in our case LEARNIFY. Now this will create a solution file in the LEARNIFY directory. Type ls to see the contents of the folder. As you can see, we have the learnify.sln file here. Now let's create a main project using the .NET new web API command, followed by the name of the project, which will contain the contents, in our case API. So type .NET new web API and the name of the folder is API. Press enter. Now let's check the contents of the folder by using the ls command. Here we have our API project. Now let's create the supporting projects using the classlib command. For this, type .NET new classlib-n and then the name of the folder. We will create two more. One of them is entity, so let's create that. .NET new classlib-n and then the name of project, in our case entity. Now we need another project named infrastructure. So let's do the same thing, and instead of entity, let's type infrastructure. Now let's add these projects to our solution file so that it can keep a track of all our related projects. For that, we have a command .NET sln. Let's check it out. It shows us the command we can use with .NET sln. We will be adding the sln add command to our three projects, API, entity, and infrastructure. What this command does is, it checks for the csproj file which comes with the web API and classlib projects. csproj file contains all the dependencies with the version. So add the solution files to our project using .NET sln add. First is API project. The second one is entity project. And finally, let's add solution file to the infrastructure project. Now we can check the files using the .NET sln list command. As you can see, we have the solution files added to the API project, entity project, and the infrastructure project. Now we have three projects and each project is dependent on another one. So to add the reference, we have a command .NET add reference. Our API project has dependency on the infrastructure project. Let me explain. Our API project will receive HTTP requests and also it will send response to the client, but it won't be interacting directly with the database. Our infrastructure project will be dealing with the database and will be sending the response to the API project. Our API project will send the response to the client. The same way, our infrastructure project is dependent on the entity project, as it will keep our interfaces which we will implement in the infrastructure project. If you don't understand it 100%, nothing to worry. It will be easier once we start working on the projects. Now, let's add references between them using these commands. Since we are in the root folder, first of all, let's go into the API project. Now, we want to add a reference to the infrastructure project, so let's use this command. .NET add reference and then the path of the infrastructure project, which is this. Now, as you can see, reference is correctly added to the project. Now let's go to the infrastructure project and add reference to the entity project. So we'll go back one step and then we'll go inside the infrastructure project. Now that we are the infrastructure project, let's add reference to the entity project. For that, .NET add reference and then the path of our entity project. Reference is added to the project. Perfect. Now, to check if everything is worked correctly, let's go back once again and type .NET restore. It will restore all the dependencies. I know this was a lot to take in, but trust me, it will make sense once we proceed with the code. This marks the end of this lesson, and I will see you in the next one. Our projects are now ready for the action. And what you need to do is open the IDE or code editor of your choice. I'm using VS Code, so let's open the LEARNIFY project. I will type code followed by a space, and then I'll press command to open the project directly from the terminal. If you want to do the same, open the command palette using Command Shift P on Mac and Control Shift P on Windows and type shell. And choose this option. The command will be added automatically to the path. Now try to open it once again. Code and command, press enter. Now, as you can see, the project is here. Now you're ready to open any project from your terminal. Once you've opened the project in VS Code, you will get a little pop-up asking required assets to build and debug are missing from LEARNIFY. Add them. This notification is from the C# extension, and we want to add this, so press yes. If you pressed not now already, don't worry. Open the command palette once again and type generate. And select this option, generate assets for build and debug. So I already have it, so I will cancel it, but you can select yes. This directory contains launch.json and tasks.json file. We will talk about them once we need them. As you can see, we have three directories: API, entity, and infrastructure, and a solution file, learnify.sln. Let's look at learnify.sln first. It's the structure file for organizing projects. It contains text-based information about the project environment and project state. For example, if you search for API, there you have it. It has all our projects and it manages the state of our projects. Inside the infrastructure directory and entity directory, there are two files and two folders each. One is a CS_proj file, which takes care of all the dependencies. It also tells us the SDK version we are using. And it also has information about the references that we have added in the last lecture. They also contain class1.cs files, which we don't need, so we can just delete them. There must be two more folders which are of no use to us. I have taken care of them by excluding them in my editor. If you are seeing them and want to get rid of them, open settings and type exclude. Click the add pattern and add **/bin and **/object and press OK. I have excluded them because they appear every time you create a new .NET project and you have to manually delete them every single time. This process takes care of the manual deletion work. Now let's talk about our API project. This must be looking different from the other two directories because remember, this is our web API project and also our starter project. Every request will first hit this project before going anywhere else. Inside the properties folder, there is a launch settings.json file. The settings that are present within this file are going to be used when we run the .NET application. Since we have just created the project, the environment is development. And depending on which IDE we are using, different profiles will be invoked. If you're using Visual Studio, it is going to invoke the IIS express, which will start the server on the random URL. For us, if you're using Visual Studio Code, it will use the API object, which will run a server on HTTP server 5000 and HTTPS server 5001. By default, it launches the browser when the server starts. I find it annoying, so I will turn it to false. You can choose as per your convenience. By the way, it uses Swagger on the browser to list our API endpoints. If you don't know what Swagger is, Swagger allows us to describe the structure of your API so that machines can read them. Let's get rid of the HTTPS endpoint because we don't need it in the development process. Now, rather than using the terminal from outside, we can use the integrated terminal which VS Code provides us. To open the terminal, press Ctrl and apostrophe, which is below the escape key. This will open the integrated terminal. Now, to start the server, let's go inside the API folder using cd API command and run the command .NET run. This will start our server. As you can see, the server is running on HTTP localhost 5000, exactly as mentioned in the launch settings.json file. To stop the server, you can type Ctrl+C. We can also see that the hosting environment is development. At the bottom is the root path, which is users, my name, desktop, Learnify, and then the API folder. Let's stop the server by using Ctrl+C. Now, rather than using .NET run command, let's use .NET watch run command. This will keep an eye on our projects and will show us the changes without restarting the server. Let's look at the program.cs file. This will be familiar to you if you have worked with C# before. When we run the command .NET watch run, this main method is invoked. Inside this method, it's calling a create host builder method, which is located below. This method is responsible for hosting our Kestrel web server and hosting it on our localhost 5000. This method also adds some default configurations to our project. As you can see inside the configure web host defaults, it uses a startup class, which we are going to see next. It also loads the environment variables that come from the appsettings.json file or from the appsettings.development.json file. Let's take a look at them. Our appsettings.development.json file will only run if we run in the development environment. It has some default logging settings. Let's change Microsoft from warning to information. It will help us giving the detailed logs. The appsettings.json file will run regardless of any mode we are in, development or production. Now let's take a look at the startup.cs file. First of all, we have the startup constructor, which takes as parameter I configuration. What we are achieving by doing this is we are injecting the configuration inside our startup class. The I configuration parameter will give us access to the variables that we are using inside appsettings.development or appsettings.json file. Our appsettings files are nothing but key value pairs of information. The configure service method adds services to the container, such as the token services or the email services. Currently, it has the add controller service, because of which our project can take and respond to the HTTP requests. It also has a Swagger service, which is also giving shape and documentation to our APIs. Although we are not going to use Swagger intensively, we will use it briefly later on. Coming back to the method, use configure services method to add dependency injection to your project. Now let's talk about the configure method. It says, use this method to configure the HTTP request pipeline. Since we are making a web application, job of our application is to take HTTP requests and sending back the responses to the client. Handling HTTP requests is a process which is sequential, and that's why it's called a pipeline. So if you want to add any middleware inside the HTTP pipeline, such as CORS or redirection, correct sequence needs to be followed. So in short, we will be adding our middlewares inside the configure method. We already have few of them here. This one checks if we are in the development process and run these commands only then, such as Swagger and use developer exception page, which sends us the page as an error response. Down bottom, we have HTTPS redirection, which we won't use since we are not using HTTPS in development. It also has app.useRouting, which takes care of all the routing inside our project. We have app.useAuthorization, which we'll use later on. And finally, we have app.useEndpoints. This middleware will direct our requests to our endpoints. So this was a brief walkthrough of our projects. I don't expect you to understand everything at once. It took me a lot of time understanding the purpose of every element. But we are going to use these files again and again, which will help you to get used to the interface. Now, before ending this lesson, let's check if our server is running in the browser. Open your browser. Go to the URL http localhost 5000. Oh, there's nothing in here. We don't see anything. Don't worry. We are listening on http localhost 5000/swagger. As you can see, there is a demo API. Let's check it out. Click on get and then click on try it out. Finally, click on execute. This will send request to the weather forecast endpoint and send back a response, which you can see here. All right, that was a lot to absorb. Take a coffee break and come back where we will see our controllers in the project. Now, as you can see here, we have some data as part of the response. If you're following along, you'll see the same data here. We can see this response because we hit the weather forecast endpoint. You can see this beautifully managed because Swagger is taking care of all this. As we discussed in the last lesson, Swagger is a documentation tool for our API. So all the endpoints we make in our project will be displayed on this page. You can run it or troubleshoot it. Currently, we only have one endpoint, weather forecast, which comes bootstrapped with our web API project. This was just the little overview of Swagger, but as mentioned, we will be using Postman to test our endpoints. Now, let's go back to our code. You saw the response. Now, let's see why we saw what we saw. Inside the API project, we have controllers folder. In our controller folder, we have a weather forecast controller file. Now you can guess from where did the weather forecast endpoint come from. As we saw in the last lecture, we have configure method, which has a middleware called app.useRouting. Now this middleware looks at the endpoint of the HTTP request and sends it to the appropriate controller. Now let's go inside our controller. We have all our declarations on top. Below that, we have a controller. Controllers in our web API are classes that are derived from controller base. The controller base class provides many properties and methods that are useful for handling HTTP requests. Let's take a look at some of the methods. Click on the controller base and press F12. It will take you to the controller base class. Now let's search for bad request. This error is displayed when the request received by the server cannot be processed. Let's look at another method. Let's search for not found. Here we go. Now this error indicates that the server can't find the requested resource. Now let's go back. If we hover over it, it says a base class for an MVC controller without view support. If it were a MVC project, controllers usually come with view support. Since we are only using .NET for the API, so we don't need to serve views right now. We will let React provide us the user interface. Everything inside the square brackets are called attributes. The API controller attribute makes routing a requirement. It also displays validation errors automatically on your behalf if there is any model validation error. So if the state of the model is invalid, it will automatically trigger the HTTP 400 response. Now coming to the root attribute, it has a placeholder called controller. So what it does is it checks the name of the class and removes controller from the name and make it the endpoint. For example, from the weather forecast controller class, it will omit the controller keyword and make weather forecast the endpoint, as we saw in the browser. So when we hit the endpoint, if the endpoint has get method or get request, it will invoke this method. This method is responsible for sending the arrays of date, temperature, and summary back to the client. Now the entities we are sending back as a response are defined inside the weatherforecast.cs file. Right now it's inside the API project, but later on we will move all our models to the entity project. If we look inside this file, we have 4 properties. It starts with public, which means it can be accessed by the same class or by any other class in any assembly. Then it has the data type followed by the name of the property, and finally it has a getter and a setter. If you are coming from an object-oriented background, you'll be pretty familiar with it. Basically, they are just accessors and mutators, where get returns the value and set mutates the value. Now, if it's not written in this way, it can also be written as this. Get is returning the value and set is mutating the value. Now you can shape it in any way you want, but since we are just initializing the value, it will be like this. So you can write it like this, or in an easy way, it's written this way. Now let's take them off. So basically, these properties are returned back to the client. In this course, we are going to make plenty of controllers. So don't worry if you are missing out on something. In the last lesson, we saw our only weather forecast controller. We tested our endpoint using Swagger, although Swagger works fine, but we will be using Postman in our project. Let's see how it works on Postman. First of all, download the Postman collection file from the code below. Open the Postman tool and click on Import. Now you can drag the downloaded file here or click on Upload Files. Now you can click on Import. If you are not able to download the file from the code below, inside the course assets, you will find a file called learnify.postman.json. Download the file and do the same thing. Click on Import and import the file here. Now, open our project, click on Module 1 and open the Get Weather Forecast request. Now, we can click on Send. It has everything loaded up. We see the exact same data we saw inside our browser. Now, this was it about the lesson, and now I will see you in the next one. In the weather forecast controller, we saw few properties such as temperature, date, and summary. In this lecture, we will create our own properties. When you go to an e-learning application, which properties do you see in a course? There is an image, name of the course, price, duration, name of the instructor, maybe rating. Now, let's implement these properties first. Now, right-click on the entity folder. You will see an option to create a new class. You are able to see this because of the C# extension we installed. Press right-click, click on Create a new class. Give this file a name of course because this is our course model. As you can see, namespace is entity because it's the name of our project. Underneath that is public class entity. Now we can start writing our properties. Let's start with the ID property because every course will have a unique ID. It starts with public as we want to access it from any project, followed by the data type, which is GUID. It stands for Global Unique Identifier. It is a 128-bit integer used as a unique identifier. Earlier, it was called UUID, which is Universally Unique Identifier. But now it's GUID because it has very low probability of being duplicated because it's a 128-bit integer. Now, the name is going to be ID. You can call it anything you want, but it's conventional to call it ID. Finally, it has a getter and a setter. We discussed why it's represented the way it is. Now you must see a red underline under the GUID, which means it's not available in our environment. What we can do is click on GUID and press Command and dot if you're on Mac, or Control and a dot if you're on Windows. It will show you some options. What we want is system. As it belongs to system, so click on systems and you will see an import system again, so many systems, and the error will go away. Now let's move on to the next property, which is title. Now let me tell you the shortcut. Type prop and press tab. You will see it creates the entire property by itself. Now you can edit it as per your preference. In the title property, data type is a string and the name is title. Getter and setter will stay the same. Now let's create rest of the properties. We need price, and for price, data type is going to be a float. Float contains value till 2 decimal place, and that's what we want. Next property we need is the name of the instructor. Data type will be a string and name is instructor. Next one is going to be the rating. Data type will be a decimal and name is rating. Finally, the image property, where the data type is going to be a string and name is image. Getter and setter will be the same for now. That was it for now. In the next lecture, I will introduce you guys to the entity framework core. I want you guys to know it before we start implementing it in our project. So that was it. I will see you in the next one. In the last lesson, we created our very first model. Now it's time to make a connection with the database. As discussed, we will be using Entity Framework Core to do this. Let's see what exactly is Entity Framework Core. It is the latest version of Entity Framework. Its previous version was Entity Framework 6. It is lightweight, open source, extensible, and cross-platform. So you can use it on any other platform. The most important thing to know is that it's an object relational mapper, which I'm going to talk about in the next slide. For now, you can think of it as an alternative to ADO.NET, which again establishes a connection with a database. The best thing is it lets you write database queries in a single language. Since you're using C# to write your queries, you use LINQ over SQL, which makes the queries much more optimized. Also, you don't have to create the database. You just write models and it maps them to the tables easily. Now let's understand what exactly is an ORM. Well, it stands for Object Relational Mapper. What it does is, it establishes a connection session with a database. It lets you query and mutate the database using the object-oriented paradigm. You use the language you know to query the database. So it's fine if you don't know how to write SQL queries. Since it's not a direct connection to the database, it abstracts from the direct connection. And switching the database becomes easy since you're not writing the database's language. You just change the database and it works the same way. You don't have to manually write big SQL queries, which saves time. And since you write less code, chances of making an error is lesser. One great thing about it is that you write the model and it makes database table out of it. Now let's see how it fits to our architecture. When we have an application, it has objects such as a user or a course in our case. If we want our data to persist, we need a database. And for smooth communication, we need a secure connection between our application and the database. So the ORM provides us that connection. You also have an option to do it without using Entity Framework Core. But for that, you'll have to manage SQL connection. You'll have to set up a SQL data reader class, which reads data from tables row as it were coming from a data stream. You'll have to set up the stored procedures, which lets you use the repeated database queries. You'll also have to know ADO.NET, which also creates a connection with a database, but it doesn't come with other features that Entity Framework Core provides. Not just that, you'll be responsible for mapping the objects to the database. But if you use the Entity Framework Core, what you need to do is install Entity Framework Core and create a connection with a database. That's it. No more hassles. It's very flexible as you can easily switch the database. Even if that's not enough, let's look at some advantages of using Entity Framework Core. You write models, it makes it a database. We will follow a code-first approach rather than database-first approach, which means we don't have to design our database. We just need to write which properties do we need, and it takes care of the database design. It saves a lot of time as it does all the repetitive tasks. Like we discussed, it makes switching the database very easy. It creates a secure connection to the database. It manages mapping by itself. It uses LINQ for writing queries, which are very optimized. Also, it lets you write code in just one language. I hope you understand why we are using Entity Framework over manual database connection. Now that we know what it is, let's implement it to our project in the next lecture. In the last lecture, we discussed what Entity Framework is and what are the advantages of using it. To download it to our project, we will use the NuGet Gallery extension that we installed in the introduction module. If you haven't installed it yet, go to Extension, search for NuGet Gallery and install it. Once it's installed, press Command-Shift-N-P if you're on Mac or Control-Shift-N-P if you're on Windows. Now, once the search box is open, search for NuGet Gallery and select it. It will take you to a different tab where you search for the required package and install it. We are looking for Entity Framework Core, so search microsoft.entityframeworkcore.sqlite, since this is going to be a development database. Choose this package and select infrastructure, since this is where we'll create our data context. Make sure the version you're selecting is same as the runtime. If not the same, make sure it's the closest one. If they are far off, you might get into some issues. Now, press install and you see it's installing the package. Make sure there are no errors. Now, close the tab, open the infrastructure project. Let's create a file and name it store context. Well, you don't have to mention .cs, it does that automatically. Once the file is made, let's derive from DB context class, which is provided by Entity Framework Core. If we hover over it, it says a DB context instance represents a session with a database and can be used to query and save instances of your entities. DB context is a combination of the unit of work and repository patterns. We discussed that it creates a session with the database, and don't worry about the repository pattern and unit of work for now. We will be using these two as part of our architecture. It also says typically you create a class that derives from DB context and contains DB set of type tEntity properties for each entity in the model. If the DB set of type tEntity properties have a public setter, they are automatically initialized when the instance of the derived context is created. We created our models 2 lectures prior, and as you can see, we have public setters. So this means when we create a new instance of a context, they will be automatically initialized. Now coming to our store context class, put your cursor inside DB context. Let's create a constructor. Let's choose the one which has options since we want to use the methods inside the DB context class. Now let's take off the not null attribute since we are not going to use it anyway. But what we need is the DB context options, and then we pass in the options and then we use the base, which is the constructor inside the DB context class we are deriving from, and then pass through the options to the class. Now below that, let's create our first database table which will contain our course properties as columns of the table. To create a database table, write public followed by a DB set. Our DB set will be of type course. Since we want to map the course properties to the table, we'll give it a name courses since this is going to be the name of the table. Finally, we end it with a getter and a setter. This is how you configure a database table. So whenever you need to create a new table, create a DB set just like this. The approach we are taking here is the code first approach, where we just write the properties of the model and our ORM maps it automatically to the database. This approach is convention based. What I mean here is, if we take a look at our course model, we have named our unique property ID because this is a convention. And because it's named ID, Entity Framework Core knows that it's unique and it will be a primary key of the table. And primary key of the table is non-nullable. So this is an example of a convention. If you name it something else, it will be difficult for Entity Framework Core to select a primary key of the table. And if you know SQL, you know that every table must have a primary key. Now, moving on, you remember the configure services method in the startup class? We need to register the database service in our startup class so that it's available from any project. Let's go back to our startup class, go inside the configure services method. This is where we need to register our DB context. Entity Framework gives a method to add a database. So let's type services.addDBContext. This is going to be of type store context. That is the class we created in the infrastructure project. Inside, it will take some parameters. In our case, since we are using SQLite right now, we need to add that parameter. It gives us an error, which means we need to import it from Entity Framework Core. We also need to bring infrastructure so that this error is also removed. Now our SQLite connection requires a connection string. We are going to get a connection string from iConfiguration. Since we are here, I would like to mention something. Everyone has a preference, and in C# world, there is a convention to use. Let's remove iConfiguration and also this from inside the constructor. Let's make configuration short to just config. Now put your cursor on it and use quick fix using command and dot, or control and dot if you're on Windows, and select initialize field from parameter. It will create private read-only field called config. It will map the same property inside the constructor. It's possible that you didn't get a underscore config file. That's because I have chosen it to be this way through settings. If you want it to be the same way, go to settings, search for private, click on C# extensions. As you can see inside the private member prefix, I have selected an underscore. This is the prefix for generated private member declarations. This is not necessary to use it the same way as I do, but this is a convention to use underscore as a prefix to private fields. You would have also noticed that my constructor is not using this keyword. This is something that I've tweaked as well. To take that off, search for this and inside the extensions, select C# extensions. You will see an option which says whether or not a constructor assignment of a property or variable should be prefixed with this. Unselect this option. That's it. We will use this underscore config to get a SQLite connection string. Now let's go in underscore config.get connection string and name it default connection. Now let's add our connection string since we haven't added that yet. Let's go to the app settings.development.json file. Below our logging part, let's make our connection strings since this is where our I configuration is going to look for. Since we have mentioned the key default connection, let's mention that here. Since we are using SQLite, we just need to mention data source. Let's name our database learnify.tb. Make sure the spellings are correct before you move on. Before we see the database in our project, let's create migration in the next lecture. In the last lesson, we added Entity Framework core to our project. If we go back, we named our table courses, since this is going to have all our course related properties. If we go back to our course entity class, this is going to be our table columns. This is not the final version. We'll be making changes as we move along. Now, to make the database appear in our project, we'll have to make a migration. Since we are talking about migration, let me remind you that we are using code first approach, because of which Entity Framework Core is responsible for transforming your properties into a database table. Now to make a migration, we'll have to go back to our terminal. Let's go back from API project to the root of our project. To make migrations, we need to have Entity Framework tools. Let's see if I have it. Type .NET tool list -- global. As you can see, my tool list contains .NET EF. If you don't have it, go to nuget.org/packages/.NET-EF. You can see the command we need to install the tool. Make sure it matches your runtime or it will show you a warning. Now copy this command to your clipboard, go back to the terminal and run this command. To me, it says .NET EF is already installed. You won't see it if you're running this command for the first time. You can use the same command to update the tool. Just replace install with update. I won't do it since I'm using the latest version right now. Let's run .NET tool list -- global again. If it's correctly installed, you will see .NET-EF listed. To check which all features .NET EF tool provides us, type .NET EF-H. On top, you see options, out of which we already selected .H. If you look at commands, we can manage database, TP context, and migrations using the tool. Since we are going to make a migration, let's see which all commands we can use with migrations. Type .NET EF migrations.h. We have an option to add, list, remove, and to create a script. We will use the add command, so let's clear it and type .NET EF migrations add Let's call it first migration since it requires a name. It also needs to know the name of the project, which is infrastructure, and also name of our starter project, which is API. Now our final command is .NET EF migrations add, then the name of the migration, which is first migration, -p, which stands for project, and our project is infrastructure, then -s, which stands for the starter project, which is our API project. Now our final command is .NET EF migrations add, first migration -p, infrastructure -s API. Now let's press enter. Oh no, we see an error. It says your starter project API doesn't reference Microsoft.Entity Framework Core.design. This package is required for the Entity Framework Core tools to work. Ensure your starter project is correct, install the package and try again. Alright, it tells us what to do. We have to install Microsoft.Entity Framework Core.design package to our API project since that is our starter project. So let's go back to our command palette, open the NuGet gallery and search for this package. Alright, we found the package. Now click on it and install it in our API project. Once it is installed, let's go back to our terminal and rerun the same command. Now we see success. It says Entity Framework Core initialized store context using provider Microsoft.Entity Framework Core.SQLite. Perfect. Now let's see what it has created. As you can see, we have a migrations folder inside our infrastructure project. It has created 3 files: the data context, model snapshots, and the designer file. These files are just to allow Entity Framework to keep track of what migrations have been created so far. It helps to switch back easily to a previous migration. If we look at the first migration class, it has derived from migration class, which is the core Entity Framework class. Below that, we have a migration builder, which creates a table for us called courses, as we mentioned in our store context file. It has mapped to all our course properties, and if you see below, it has made our ID property the primary key. We discussed that code first migrations are convention based, and this class has gone with the convention and used our ID property as a primary key. This is usually the primary key in SQL tables as well. So we have 2 classes here, up class and the down class. Up class created the table and down class dropped the table. Now we are done with the migration, and in the next lecture, we will create our database table based on this migration. So I'll see you in the next one. In the last lesson, we created our first migration using the code first approach. .NET EF tool helped us to create the migration. Let's see what we can do with the database now. Let's clear the terminal and type .NET EF database -h and press enter. As you can see, we have an option to update and to drop, which makes it very clear which one we want to use right now. The update command will create the database upon the migration we created in the last lesson. It is built upon the latest migration and make the changes accordingly to the database. This is our first time and we don't want to look for the changes. It will create the database from scratch. Well, this is one way of creating it and it certainly works. Try it if you want to, but we want our database to be filled with some data when it first starts. So what we want is to check if there is any database. If there is not, we want to create a database and fill it with some initial data. To do this, we'll have to go to a class which is invoked first when the server starts. And it's a main method which is inside a program.cs class. To set it up, we need to make some changes to our main method. First of all, we'll have to put this method inside a variable. Let's name it host and remove run for now, because we want to set up the migration before we finally run this method. So our host variable is storing this command. Let's create another variable and call it scope. This variable will contain host scope. We see an error, which means we have to run the quick fix and call dependency injection to this class. What we want is to dispose this variable after we have finished using it. We don't want it to be hanging here forever. So we will use the using keyword before this variable. And what it'll do is, it will dispose this variable after the method is correctly executed. It is one of those things we want to dispose of after we are done using them. So basically, it will create a scope for services we are going to use in this method and dispose it after it's done. Below that, we are going to create a variable called services, and it will store scope.serviceProvider. Now, we are going to call our database service and there might be a chance of failure. To handle the errors, let's create a try and catch block. Inside the try block, let's create a variable called context and it will store our database service. So it will be services.getRequiredService and it will be of type store context class that we created. Now let's use the quick fix using command and dot on Mac and control and dot on Windows, depending on your OS. Now let's select infrastructure and the error is gone. If you remember, we have added the database service in the startup class as well. In this case, we just want to store that service in the context variable so that we can use this service when the server starts. To make sure we are using the latest migration to create our database, our context gives us a method to do that, which is context.database.migrate. Now let's resolve this error using the quick fix. Let's call Microsoft.EntityFramework.co. Now it's resolved. If we hover over it, it says it applies any pending migrations for the context to the database. We'll create the database if it does not already exist, and this is perfect for our use case. We want if there are any pending migrations, it should apply that while starting up. And if there are no databases, it will create it. Now, if something bad happens and it fails, for example, if there is no migration or there is some connection problem, we need to handle that. We have another service called iLogger, which simply logs the problem to our console. So let's use it. Var logger is equal to services.getRequiredService, and the service is iLogger. It takes a type, which in this case is our program class. Then we'll write logger.logError. First argument will be the exception and second will be the message. Let's type something wrong happened during migration. This finishes our try catch block. Do you think it's gonna work? I don't think so because we haven't called the run method yet. So let's do it. Below the try catch block, let's write host.run. Now it's ready for the action. Let's go back to the terminal and clear everything. Let's go inside our API project and type .NET watch run. Let's check out the messages. We see EF migration history, which means our code has worked. Below that, we can see that all our course properties are listed here. I'm so excited to see what it has created. To see that, let's open our command palette once again and type open database and click this option. Now you will see this option only if you have installed the SQLite extension. If you have not, please pause the video and go ahead, install the extension and come back. If we click on the option, you see our database learnify.db is showing. So let's click on that. In the Explorer window, there is a SQLite Explorer. Open that and inside learnify.db, we have our courses table and _EF migration history table as well. It keeps a track on our migrations. Let's open that. It shows us the migration ID, We currently have just one migration. When we do more migrations, they will be added to this table, and we can switch back to previous migrations as well. If we open our courses table, we are going to see nothing because we haven't created any data for our courses table. I know what to do next. In the next lesson, let's create some data and seed it to our database. Now that we have our database set up, it's ready to accept data. We could have created the data using the queries or using the API request, but I wanted to show you how you see data in Entity Framework Core. Let's go back to our infrastructure project and create a new file. Since this file will help us seeding the data, let's call it storeContextSeed.cs. Inside this class, we will create a static method. A static method can be used without creating a new instance of the class. Now, let's create the static method public static async task, and let's call it seed async. Since in this method we are talking to our database to check if it's empty, we need to make it asynchronous. And that's why we have used the async keyword and the task keyword. A task is an object that represents some work that should be done. The task can tell you if the work is completed, and if the operation returns a result, the task gives you the result. In this case, we are not returning any response. That's why we have mentioned only task. Suppose if we were expecting a string to be returned, it would have been task of type string. All the asynchronous methods we create, we will use the task object. Now, let's add the parameters. In this method, we need our store context. So let's write it down. Let's give it a name context. We also need iLogger to log the information. Let's give it a name logger. We see plenty of errors here. You know what to do. Let's go to each of them and use quick fix. Let's go to task. Let's import it from Microsoft.threading.tasks. And now let's go to iLogger and import it using Microsoft.extensions.logging. We see a little warning because we haven't used anything asynchronous so far. Don't worry about it just yet. Now, to handle the errors, let's create a try-catch block. First of all, we need to check if there is any data in our database. To do so, we'll use an if statement which checks if our database is empty. So, if context.courses.any, we'll use a bang operator which checks the opposite of it. So, this statement is checking if the database is empty. We want a method to read data from the file and add it to the database. So the statement is checking if the database is empty. We want a method to read data from the file and add it to the database. You must have downloaded the course assets folder. Open the folder and copy the courses.json file. Now, inside the infrastructure project, create a new folder and name it seed data. Inside that folder, paste the courses.json file. If we look at the file, we have some course data which includes rating, instructor, title, price, and image. These are the properties we defined inside our course model. Let's store this file inside a variable and let's name it course data. Now, if you want to read text from a file, you need to write file.readAllText method, and inside the method mention the path. Since this method is going to run from program.cs file, which is inside the API, we need to go out from the API directory and inside the infrastructure project, then the seed data folder, and finally the courses.json file. We see an error because we haven't imported system.io, which provides file method. So let's use the quick fix and import it. Then what we want to do is to serialize what's inside the courses.json file into our course object. What we can do now is to create a new variable courses and equals to JSON serializer, which we can import from system.text.json. Once the error is gone, we can say .deserialize. Then we have to mention the type of model, which is the list of course model. Then inside it, the course data, which has all the JSON data. Let's import list from system.collections.generic and course from the entity project. Once it's deserialized, we can store this into our database using the store context. Let's create a for each loop. Let's write var item in courses, which stands for an individual course object. Then we will write context.courses.add and then specify the item inside the method. Right now, our context has tracked everything and the data is stored in memory, but it's still not added to the database. For that, let's go outside the loop and mention await context.savechangesAsync. This is where all the data will be stored in the database. That's it. This is what we'll write in the try block. Now, let's write our catch block. Catch exception and let's call it X. Let's import exception from system. Inside the catch block, let's use the logger.logError method, which will display the x.message. That's it. We are done with this file for now. Let's go back to our program.cs file and inform it to see the data when the application starts. Below the context.database.migrate method, let's use await store context seed.seedAsync. Let's also pass the context and logger, which is also available in this method. We see an error because we are using await keyword, but our main method does not use the async keyword. Let's add async and replace void with task. Since we are using async keyword now, let's change migrate to migrate async and add await in front of it. We can also change host.run to host.run async. Let's add await keyword here as well. It still shows an error because variable logger is in the catch scope. Let's place it above the try and catch block and we are done. Like I mentioned earlier, this is a static method and that's why we don't have to create a new instance to call this method. Now, all we need to do is stop the application and restart it to see the course data inside our database. Open the command palette, type open database. Inside the SQLite Explorer, let's open it. Inside the course table, right click on it and click on show table. And yes, we finally can see the data inside our table. Perfect. We can see all the properties we seeded inside the database. And in the next lesson, let's get this data using the API. I will see you in the next lesson. We have successfully seeded the data in our database and we can see it in our table. Now, we want to query the database and for that, we will have to write our controller. First of all, let's open the API project and check what's going on inside the weather forecast controller. In this project, we are going to create a lot of controllers. All of them will derive from the controller base and will share the similar attributes such as API controller attribute and root attribute with controller placeholder. Since we are sharing this part in all our controllers, rather than repeating ourselves in each controller, let's create a base controller which will include all of this and we will derive from that. Let's create a new class and name it base controller. As mentioned earlier, we will derive it from controller base, which is same as we saw inside the weather forecast controller. Let's use quick fix and import it from microsoft.asp.netcore.mbc. One step is done. Let's also use both the common attributes above this, API controller attribute and the root attribute with API/controller placeholder, since we want our endpoints to start with the API root. This placeholder will be replaced with the name of the class, which we are going to name courses controller. and the root will be called API/courses. Let's create the class now. Right click on the controller folder and click on new class. We are going to call it courses controller. Let's derive it from the base controller we just created. We will be using services inside the controller, for which we'll have to create a constructor. Let's put the cursor on courses controller and use quick fix. Choose generate constructor courses controller. Our constructor is now ready. To query our database, we need store context here. This is not going to be part of our architecture, but just for the time being. Let's call the store context here and let's call it context. Let's bring it using infrastructure. To make this context available for all our methods, let's go to context and use quick fix. Let's select initialize field using parameter. I'm telling you again that this practice is not recommended. We are doing it just for the time being. We will abstract the database using repository pattern in the future lessons. We are using this method just for demonstration purpose. Below it, let's create our get method. Let's write http get inside the square brackets. Below that, let's write a method. Public async task. Return type is going to be action result of list and the list will be of type course. Let's call this method get courses. We see a lot of reds here. Let's resolve them using the quick fix. Let's call http get using microsoft.aspnetcore.mbc. Let's import task from system.threading.tasks. List will be imported from system.collections.generic and course from our entity project. Now, let's go inside the method and let's return our data. We are going to return the list of our courses. Let's write it down here. Await underscore context dot courses dot toList async. Let's import it from entity framework core. There is nothing much going on here. We are just returning the data as it is from the database. Let's create another get method, but this time it will take a root parameter called ID. This method will return the course with the particular ID. If you want to pass an argument inside the HTTP attribute, you need to pass it inside curly brackets. The endpoint in this case will be courses/ID. Let's write a new method. Public async task action result of type course. Since we are looking for a single course with the particular ID. Let's call this method getCourse. And inside the parameters, we want to mention the ID which is of type GUID. Let's bring GUID using system. Inside this method, let's return await underscore context dot courses dot find async and we'll mention the ID. Find async method will give us the course with the ID we mentioned inside this method. To make sure things are updated, let's restart the server. Although it's not necessary, but we'll do it this time. Now, let's go back to Postman and select get courses request from module 1. You must be wondering what exactly is URL here. This is a variable which we can store inside our request. If we go to the right hand side of the LEARNIFY collection and click on the three dots and click on edit, go to variables tab, we can see our URL variable with initial value and current value, both set to localhost 5000. Since we are using this endpoint for development stage, you can change the variable if you're using any other endpoint such as HTTPS 5001. Let's make the request now. We get a 404 not found error. And I might know the reason why. Let's go back to our code and check our base controller. And yes, I know where I did the mistake. Did you notice the error as well? I forgot to add the square brackets around the controller placeholder, which means there was no endpoint called API/courses, and we were hitting a random URL. Let's place the square brackets now and save the code. Now let's go back to Postman and rerun the request. And yes, it says 200 OK and returns the data which we seeded in our database. Let's now pick the ID from any of these courses, use it for getCourse method. Replace the ID here since it's going to be unique. Now press send. We see the course with this particular ID. Perfect. We have achieved what we expected from this module. Next, we will show these courses to the client for which we will be using React. So let's tackle our front end from the next lecture. Bye-bye. Finally, we have finished module 1. I understand it was too much for someone who's new to .NET world, and I don't expect you to remember all the steps and the sequence. This project is a big one. We are going to make more controllers, use more services, so it's very difficult to not get used to it. Now let's recall everything we did in this module. First of all, we created solution files, web API projects, class libraries using the command line interface. API project is our web API and our main project. The other two projects, entity and infrastructure, are class libraries. Entity project is where we will store all our model properties such as the course model and all the interfaces to our methods, which we'll create in the future lessons. Infrastructure project is taking care of our database related methods. It is where we have created store context, which is responsible for database creation. We then added this as a service in our startup class. We store the default connection in appsettings.development.json file. We then migrated our database, which created these three files inside migrations folder. Using the migration files here, we created our database. After that, we seeded initial data inside the database using raw data file courses.json and a static function inside store context seed. We deserialized the data and added it to our database. After which we went to program file and added the migrate method before we actually run the server. Finally, we created our own API controller called courses controller and added two methods through which we receive the data from our database. So this was it. I hope you enjoyed it so far, and in the next module, we will create our front end using React and show these courses on the browser. So that was it for module 1, and I'll see you in the next one.
Thanks for watching this new line tutorial. If you haven't already, please like this video and subscribe to our channel. It helps other students find our content.